In this video, I'm going to go over how to compute some basic derivatives and integration using the TI-89 graphing calculator. Okay, I'm going to work these without the calculator and then with the calculator. So let's look at the first one. And I'm going to assume that you have the foundation for basic calculus here. Okay, so I won't go over all of the details as far as the long procedure rate goes. But in the first one, I have a function 2x squared plus 1 to the 5th power. So using the chain rule in this, it would be 5 times the coefficient of 1 there. So this would be 5 here. And then write down the 2x squared plus 1. Subtract 1 from the exponent here to the 5, that gives me a 4. And then I take the derivative of what's inside, that's using your chain rule. This gives me a 4x. Okay, so let's multiply the coefficients out here, and we'll leave it in that product form, so this will give me 20x. (2x squared) plus 1 to the 4th. Okay, so that's the way I would do it without the calculator, just using the basic procedures. Now if I use the calculator, I would go to, this is again the TI-89, hit the second key, and then number 5 here. I'm accessing the math menu, and then scroll down to get to the calculus section, and then to the right here, and then number 2 is derivative. So hit enter. It's already highlighted, so hit enter, and then I just enter this. So in parentheses, it'll be 2x to the 2nd plus 1, and then parentheses, and that quantity is to the 5th power. And then I put in a comma, and then I have to indicate the variable we're using, so x, and close parentheses, hit enter, and there you have it. The derivative is 20x, and quantity 2x squared plus 1 to the 4th. Okay, clear this. Okay, second one. The derivative of tangent x, okay, there you just have to know the formula. This one, this one has an answer of secant x quantity squared. So I can put the square right here, or I can put the whole thing in parentheses and then put the square on the outside. Okay, either way it's the same thing. Now if I do it in the calculator over here, then again I go to the math menu over here, 5, 7, and then 5, and then scroll down. Calculus to the right, again derivative is highlighted, 1, and then enter the tangent. That'll be second key, and then the t here, tangent, into the variable x, and then comma, indicate the variable x, close parentheses, and hit enter. Okay, and because of the way this thing is programmed, it gives you pi over 180, and then also the cosine x squared. Okay, so let's just remember that pi and 180, pi is in radians and 180 is in degrees. These are equivalent, so if I cancel those out, I'm left with 1 over cosine squared x. So notice I'm putting the square here, which is the same thing as putting parentheses and then putting the square. But if you know your trig identities, 1 over cosine squared, 1 over cosine squared x is the same thing as secant squared x. Okay, so this type of thing might come up on some others, so you keep that in mind. Okay, and it's because of the way it's programmed. Let's clear this. Clear this over here. Let's go down to the next one. Okay, here we want to compute a limit of this thing right here. So if you know your basic algebra, you think of this as a rational function here. What happens to this thing as x goes to infinity? Basically, as x goes to infinity, you're going to be left with 8 over 2, which is 4. And I can do that by dividing everything by x. This will leave me 8 plus 1 over x, and this will leave me 2 minus 3 over x. But as x goes to infinity, these terms over here cancel, and that leaves me with 8 over 2, which is 4. So this would suggest then that if I'm graphing the function 8x plus 1 over 2x minus 3, it would have a horizontal asymptote at y equal to 4. Okay, but we're going to do it in the calculator here, so get the calculator. So again, second and then 5 gets me the math menu. Go down. Calculus, and this time I want the limit. Okay, so I hit number 3, and then I'm going to enter this function here. So I'm going to put parentheses 8x plus 1, okay, divided by, and then parentheses 2x minus 3. Okay. And then I'm going to indicate the variable here, so I'm going to put a comma x, and then a comma, and again, then you could have limits as x goes to infinity or minus infinity, or x could go to a number like 2 and so forth. But here it's infinity, so the second value I put will be infinity, and that's right here. In catalog, so I hit this color, this little icon right here, diamond, this, and then catalog the x as is the infinity. Close the parentheses and hit enter, and there's the setup. The limit of this expression as x goes to infinity is the number 4. Okay, so did it both ways for you. Clear this. Okay, clear this, and let's go to the next one. Okay, now here we're just doing a basic antiderivative. Okay, antiderivative or integral is just the opposite of the derivative. Okay, you take a function and you take the derivative, you get another function, and you take the antiderivative of that, you get back the function. So here we're just doing actually the opposite of the derivative, and I kind of mixed it in so that you can see how it works when you have a regular monomial or an exponential or something like 1 over x, a rational expression. So again, go second, math, and then calculus. And here we want the integral, we want to integrate. So we hit 2, and then we enter this function here. Okay, so this will be x, and then a power of 2, and then plus. And we want the exponential here, so that's this one right here. So I hit this icon right here, this diamond here, go second, and then hit this x. I'm accessing the exponential. And this is 2x, so this will be 2x, close the parentheses. And then plus 1 over x, 1 divide by x. Okay, and then I have to indicate the variable. The antiderivative or the integration is with respect to x, so I got to go comma x, close parentheses, and hit enter, and there it is. Okay, it's not in this particular order, so if I was gonna work this out without the calculator, I would come out here and say, okay, I want the integral or the antiderivative of this expression. So I actually go term by term, and I use specific formulas for the corresponding term. So if it's an x squared, I add 1 to the power there. I get x to the third, and then divide by that same value. I get that. Okay, for the exponential, it would be e to the 2x. And then I divide by actually the derivative of this right here, which is 2. Okay, derivative of 2x is 2. And it goes this way. And then there's a formula for the antiderivative of 1 over x, or the integral, and that's 1 over, or I should say, the natural log of x. Okay, this is what is called an indefinite integral. So whenever you evaluate an indefinite integral, you're going to add a constant. The derivative, okay, the derivative of any constant, 2, 3, 4, pi, whatever, is always going to be 0. Now the calculator doesn't give you that part, but there it is. Okay, natural log, that's this one right here, and I guess I need absolute values here. X to the third over 3, that's over here. Okay, and then e to the 2x over 2, that's this term right here. So there you have it. Okay. So if you're just finding the integral, your answer is always going to have a constant. Now, if you're doing something like what's called a definite integral, where you have a lower limit here of 0 and an upper limit of 3, there you're not going to have a constant. The answer is going to be a numeric value. Notice this calculator gives you a symbolic answer. The TI-89 and some other calculators, well, you can't work these types of problems with symbolic answers. You might be able to compute numerical answers, but not symbolic answers like this one. Now, for the last one here, clear this out, and then clear this. This again basically works kind of like this one, except we have a lower and an upper limit. So when you compute something like this, you're actually computing, in this case, it's going to be an area under a curve. Usually in this case it'll be bounded by the, so in other words, what this will give me is this. So the function is y equals to x squared, so that's a parabola. Okay. Vertex at the origin. So it goes like that. So I go 1, 2, 3. So this will be, say, 3 here. This will be 0. So I'm going from 0 to 3. So the value that I get is actually going to give me the area right in here that I have shaded, bounded by the curve, the x-axis, and the line x equal to 3. Okay. So I've been doing these both ways. Okay, so on this one, if I did it without the calculator, I would simply find the antiderivative of x squared, which is x to the third over 3. It's over 3. This is evaluated from 0 to 3. Okay, 0 to 3. So I simply do this to find the answer. I evaluate this thing at 3, so replace the x by 3. I get 3 to the third is 27, divided by 3 is 9. Then I subtract the value at the lower limit. Well, put 0 there. 0 to the third is 0, divided by 3 is 0. This will be 0. 9 minus 0 is 9. So the answer is 9. So that's telling me that the area right here that I have shaded has an area of 9 square units. And that could be in inches or feet, centimeters, whatever you're dealing with. Now, if we do it in the calculator, okay, again, second, and then 5, go to calculus, and then again over to integral number 2, and I just enter the function, so this will be x to the second, okay, and then comma x, that's the variable, and then I enter the lower and the upper limits, which will be 0 and 3 respectively. So this would be 0, comma 3, close parentheses. There it tells you integral. The definite integral from 0 to 3 of x squared is equal to 9. Okay. Okay, so that concludes the video. Just a few problems to show you what you can do on the TI-89. Thanks for watching, and we'll see you next time.